If an object is thrown into the air with an initial upward velocity of r meters per second, then its distance, d meters, above its starting point at time t seconds after it was thrown is approximately d equals rt minus 5t squared. Okay? This formula, this beginning formula, I guess is what I should say, is what you'll use for every one of these problems on this page. Okay? But we've got to individualize it for every problem. Right? So let's start by talking about number 1. A football is kicked into the air with an initial upward velocity of 25 meters per second. Does that give us enough information to give ourselves a formula for this problem? Yes? Okay. So D is going to equal what? What is R? The initial upward velocity of r meters per second. Do we know that? 25 t minus 5t squared. Okay, so that's what we use for this problem, for number 1. Well, I use this exact same equation for number 2. I will if the initial upward velocity is 25, right? If it's something different, I'll have to use a different formula. Okay? Now, notice I have another piece of paper that I'm going to do my work on, because you guys know I write way bigger than this. Okay? If you want another piece of paper to do your work on, that's totally fine. If you want to write all your work out here, that's totally fine as well. Okay? We're going to start right here. Calculate its height after 2 seconds. Okay? So this is problem A. If I'm using the equation D equals 25t minus 5t squared, how would I calculate its height after 2 seconds? What do I know? I know t, don't I? Okay? And in this particular case, t is 2. So I'm going to find the height, the distance, right, the height, by substituting in 2 for t. So I'm going to say 25 times 2 minus 5 times 2 squared. Well, do you know what 25 times 2 is? 50. What's 2 squared?
4.
Times 5? Did I do that the right way? Or should I say 5 times 2 is 10 and then square that? I have to square it first, don't I? Order of operations says I have to use the exponents first. So 2 squared is 4. 4 times 5 is 20. Does anyone know what 50 minus 20 is? 30. Now, 30 answers the math problem. I want to know the answer to the question of A. What's the answer of A? What is the height? 30 what? Oh, meters. When we're working with word problems, we don't ever leave naked answers. It's not ever just a number by itself. It always has a word that make it mean something. Or 2 words, or 3 words, or something. It's got to mean something for the problem. You okay with that? Even if you're not okay with that, we're going to do it anyways. Okay? All right. Part B says calculate its height after 3 seconds. So part B, do I use the same formula?
Yes.
Okay. I use that same formula for all of number 1, right? 25t minus 5t squared is what we're using. And this time, instead of 2, we're substituting a 3. So I have 25 times 3 minus 5 times 3 squared. What is 25 times 3? 75. 3 squared? 9 times 5? What? 30? So we kick a football, and after 2 seconds, it's 30 meters above the ground, and then after another second passes, it's still at 30 meters above the ground? So you kick it up, and it goes horizontally for a second, and then goes back down? Have you ever seen anyone kick a football? Does it travel horizontally? No. What does it do? It travels in what shape? A parabola. So what's happening at 2 seconds? It's 30 meters above the ground. And then what does the ball do? It keeps going up a little more. And then after 1 second, it is back at 30. It's not horizontally for 1 second, right? So it's back at 30. 30 what? Meters. Now, you guys know I'm not making fun of you, because if I was, it would be way funnier. Okay? You know I'm trying to make you think about this problem, right? Okay. Thinking about the problem sometimes makes me pull out all the ridiculous things that some of you guys think sometimes. Okay? So even though we have some really good kickers at this school, they can't just kick a ball where it stays completely horizontal for an entire second, right? Okay. So, part C. I'm going to fold my paper so we can get it back up there. Part C. When will it be 20 meters above the ground? So you want to put 20 in for D? Why, when we're talking about 20 meters above the ground, why do you want to put that in for D? Yeah, because it's called the vertical motion formula. We're not talking about how far it's being kicked. We're talking about how high above the ground it's going, right? So we're saying, we're using the same formula, D equals 25t minus 5t squared, but we're substituting in 20 for our D, our vertical distance. Okay? So 20 equals 25t minus 5t squared. Good. Now what? How many different ways do we know to solve this problem? At least 5. Right? At least 5. We could graph it. We could factor it. We could solve using square roots. We could solve using the quadratic formula, or we could solve with completing the square. Right? What do you choose? So no matter which ones that I choose, what kind of form do I need to get it into? Standard form. So let's do that first and see how that works out. How about that? Okay, what do I do to get it into standard form? Minus 20? Like that? Oh, both sides, okay. 0 equals? Can I skip a step here? Are you guys going to be okay if I skip a step? What if I do this? Like she's saying. What did I just do? Yeah, my exponents are in decreasing order now, right? Now it's in real standard form. Anything particular you notice about all of these numbers? Should I divide them by 5? How about if I divide them by negative 5? Why would I divide it by negative 5? Yeah, that would give us a positive a value, right? We like that. Well, 0 divided by negative 5 is just 0. So I get t squared minus 5t plus 4, right? Okay, so now we're at this point. So now what do you think? Now how do you think we ought to solve this? Factoring is probably the easiest, isn't it? Guys, I know that this is called problem solving with quadratic functions. It is not called problem solving with the quadratic formula. That's just one of the weapons in our arsenal to attack quadratic formulas, right? If it's the easiest, use it. If it's not, use something else. We want to try factoring. Let's factor this. What multiplies to be 4 and adds to be negative 5? Negative 1 and 4. T minus 1, t minus 4. If that equals 0, what do I have to do? Good. Set each factor equal to 0. So t equals 1 and t equals 4. So which one's right? Are you positive that they're both right? We could plug it in, but how about if we just use some logic for a second?
Because whenever you kick it,
It's
going up and up, right? And it falls.
That's kind of parabolic, right? We'll pretend that it is. We said a second ago at 2 seconds and 3 seconds, so pretend this is a nice pretty drawing and those are all nice and spaced out, right? At 2 seconds and 3, oh no, I didn't do it. We have to start again. That's ugly. I'm sorry. Let me try again. I'll just do this. We'll just talk about it in general terms, right? At 2 seconds and 3 seconds, it was... How high was that off the ground? 30 meters. So that was at 2 seconds and 3 seconds, right? Does it make sense that at 20 meters off the ground, that would be at 1 second and 4 seconds? Yeah, can you tell me when it was the highest that it ever got? I know that's not a question on here, but use some logic and tell me when it was the highest. 2.5? Would it make sense that it's halfway in between those two, that it's the highest? Good. When will the ball hit the ground? Time out, time out. Should we plug these in and check them? We should, right? We should plug these in. 25 times 1. 25. Okay. 1 squared. Negative 5 times 1. So I have 25 minus 5. Okay, so that works, right? 4. 25 times 4. 100. 4 squared. 16 times 5. 80. 100 minus 80? 20. So they both work, right? So we should have written the answers instead of just going on. What's the answer? Or answers in this case? 1 second and 4 seconds, right? Again, we can't just leave t equals 1 and t equals 4. We have to have it mean something in the problem. Okay? Okay, letter D. When will the ball hit the ground? D equals 25t minus 5t squared. Whoa. When will the ball hit the ground? We're not just guessing. I know we could probably make a good guess, but we're not going to guess.
That means do 0, right?
What is my vertical height when the ball is hitting the ground? 0. Does that make sense? 0 equals 25t minus 5t squared. How do you want to solve it? Same kind of way? Get it in standard form? Okay. Negative 5t squared plus 25t equals 0. Now, there's not a c term. Does that help us or hurt us? It helps. It makes it easier, doesn't it? Can I still divide both sides by negative 5? Would that help some?
Yes.
Okay. So 0 equals t squared minus 5t. Is this something that I can factor? Not into a trinomial, right? But does it have a greatest common factor between these two terms? T, right? Okay. So if I factor out a t, what's left? T minus 5. And if these two multiply together to be 0, how do I solve? Yeah, I set each one of them equal to 0, don't I? Just like I do when I factor, when I get these two things multiplied together to equal 0, I set each of those equal to 0. It's the same kind of thing here. Remember that? So t equals 0 and t minus 5 equals 0, so t equals 5. So now which one's the right answer?
T equals 5.
Why is it only t equals 5 that's the right answer? Can you have 0 seconds? Yeah, that's just like when I start, right? What does this mean? Tell me about it in the
That's when it's first kick.
In the problem, right? That's when it was first kicked. When time was 0, does it make sense that the ball was sitting on the ground?
Yes.
Yes. Okay? It's not like a punt. It's like a kickoff. Does that make sense? Okay. They didn't say that. They should. I'll fix that. Okay? So t equals 0 and t equals 5. So t equals 0 is when we started. The ball was sitting on the ground when we first kicked it. So what's our actual answer? 5 seconds. 5 seconds is when the ball hit the ground. Okay? So that's the kind of thing that you're going to need on this side of the worksheet. Those are the kind of answers you're going to get, stuff like that. Okay? Look at the back of the worksheet for me, please. We're going to continue using the vertical motion formula. They went ahead and put it at the top just so you would have it. Because, I mean, it takes a long time to, like, flip the paper over. A target plane flies at 2,100 meters. An anti-aircraft gun fires a projectile with an initial upward velocity of 200 meters per second. Will the projectile ever reach the altitude of the target plane? What are the two possible answers to this question? Yes or no? Now, we can't just write yes and go on. We have to have the math to back it up, right? So let's think about what's happening here. I have this plane that's flying like that, right? And then I have the ground down here, and they're firing. I can't draw guns, so I'm just going to draw that. Okay? Plus, we're at school, I don't want to draw guns. There's 3 possible outcomes here, aren't there? They could shoot it, and it could come back down, right? They could shoot it, and it could get to that height once, right? Oh, that's a very poor parabola. Don't pretend that's a much better parabola that I drew, okay? Or, what's the last possibility? Like that, right? If it was this orange line, what would our answer be? No. If it's the red line, what's our answer? Yes, because it got to that height one time, right? If it's the yellow line, what's the answer? Yes, because it actually got there 2 different times, right? It went completely above that altitude. So notice that this is called problem solving with the discriminant, right? We talked about this a little bit yesterday. Let's remember what each of those things meant, okay? Because it's slightly different than what we talked about yesterday. What we said yesterday is if it crosses the x-axis 2 times, what's true about it? 2 real solutions, right? Okay. If it crosses the x-axis 1 time, what does that mean? I've wrote 1 real solution, and what's my discriminant? Equal to 0, right? What's the other possibility? I have 2 imaginary, and that's when my discriminant was negative, right? Now we need to make it real, because this is a real situation. Have you guys thought about that? This is a real situation. Afghanistan, World War I, World War II, United States, Japan, Germany, anytime that there's planes flying and there's missiles going off, this is a real situation, isn't there? Okay? So we need to figure out what this actually means in the situation. If I do my discriminant and I get a positive number, which one of these lines is represented by that? Yeah. If I get a positive number, it's represented by the yellow. Because I'm getting 2 solutions, one here and one here. Now, it's not the x-axis. I've changed my value of what I want it to get to 2100, right? That's where I want it to get to. What's another possibility? If it's 0, which one's 0? The red one? Because it's crossing 1 time. Remember, mathematically we get a double root there, right? What's my discriminant look like? If I get 1 solution, what's my discriminant look like? A 0. Okay? And my last possibility is when my discriminant is negative. So if my discriminant is negative, then my answer to my question here is no. If my discriminant is 0 or positive, the answer to my question is yes. Please understand, it's not saying, will the projectile hit the plane? There's a whole lot more that goes into that. You know that, right? Wind speed, direction, I don't know, aliens, I don't know. Okay? A lot more stuff that goes into that, though, than just will it get to the correct height. Okay? So let's see if we can figure that out. Let's come up with an equation to use for this problem first. What should we use? So D equals 200. The 200 is going in for R, right? That's our initial upward velocity. So 200 t minus 5t squared. So that's the main formula. Do we know any more specifics? I know 2100, right? What's that? That's my D. That's my vertical distance. What do you think? Okay. So I'm trying to get it in standard form. So can I skip a step?
Yes.
Okay. What's the next step that I'm going to write down then?
5t squared plus 200t minus 100.
Okay with that so far? Now what? Yeah, we could. We can do that. Divided by negative 5. It's not required in this particular problem because we're not actually trying to find a solution. We're just trying to find the discriminant. But it'll make the number smaller for us, won't it? So 0 equals, t squared minus 40t plus 40 what? 420? Now what? Let's remind ourselves what the discriminant is.
Oh my gosh, wait, can we use the quadratic formula?
We don't want to use the whole quadratic formula. Remember, we're just using the discriminant. What is the discriminant?
Isn't it
B squared minus 4ac. Very good. Okay? So B in this case is negative 40, right? Negative 40 squared minus 4 times 1 times 420. Negative 40 squared is 1600. What is 4 times 1 times 420? What is it? 1680. Okay. What is 1600 minus 1680? Negative 80. So my discriminant is negative. So the answer to the question is no. Questions?